In this video, I'm going to show you how to create optimized groups for small-sided games using any criteria you select. The common problem is the following. We have players, in this case 16 players over here. We have a skill rating from 0 to 10, and this might be any composite score coach use, so it might involve any technical or tactical aspect like passing, shooting, heading, one-on-one duels, or whatever. So it's some form of skill rating. I'm going to show you how to calculate the percentiles and z-scores. Mass in this case is an index of aerobic power. Might be a running test, might be a test on a treadmill, or some form of intermittent running test like 30-15. Same thing with the percentile. Z-score, I'm going to show you how to calculate the percentiles for the player for maximum aerobic speed, and how to create the composite scores between skill and maximum aerobic speed. Again, in percentiles and a z-score. Downstairs, down over here, we have mean, standard deviation, coefficient of variation, minimum, maximum. So, okay, first thing I'm gonna quickly cover is percentiles. So, percentiles in this case is from 0 to 100, and it's basically ranking players from worst to the best. So, if you sort these guys based on the skill level, so from smallest to largest, it's gonna be from 0 to 100. A formula is quite simple. You use percent rank inclusive. Forget about the exclusive version. This is a range, all these guys, and I want to rank for this score. And same thing for every other cell. The thing with the rank, the percentile, is that it kicks out the outliers, as opposite to a z-score. Z-score, in this case, for this, I can use the formula standardized. So for this athlete over here, I want to see how many standard deviations he's away from a group average. So in this case, 4.7, that's a group average for a skill, and standard deviation is 1.7. So his z-score in this case is minus 1.87. Someone who's pretty equal to the mean average, to the group average, sorry, he's going to have a z-score of 0. Usually z-score goes from minus 3 to plus 3, but that depends on outliers and distribution. So, but it's usually in that range. If the scores are normally distributed, if I remember correctly, 64 or 68% of the whole group is going to be within minus 1 to plus 1 standard deviation or a z-score. So let's see one small trick. This is a guy with the least amount of skill, or the lowest skill rating. So he has a 1.6. If we change this to 1, his percentile ain't gonna change. It's gonna still be 0, and his z-score is gonna go down a lot. So I'm gonna use Control Z. Yeah, 1.6. So what does this mean is that outliers gonna affect the z-score, but outliers ain't gonna affect the percentiles in as much as possible. One thing with percentiles also, it doesn't take into account the magnitude of the difference between 2 points. So for example, this is 1.6 and this is 2.9. So if I increase this, let's say I increase this to, need to find a good group. Okay, these three. check the percentile and check the z-score. So the percentile is on the ranking or percentiles. They only use ranking. It doesn't matter the difference between the ranks. So I can change the difference. The ranking ain't gonna be affected. So for example, 4.7. These are a lot bigger numbers, but let's say I'm gonna change it to 4.7 because I rounded it. This is 4.9. It's still gonna be 43, and this is 5.4. So in this case, the percentile is gonna change a little bit due to the formula, but the real ranking ain't gonna change. So if I change this to a bit higher, 2.5, the z-score is going to be affected a lot more than a percentile. Go Ctrl Z, Ctrl Y, Ctrl Z, see the difference. The thing is that percentiles doesn't take the ratio between two different points, and a z-score does. But in this case, z-score is also affected by outlier. And as you can see, we can use those two to create our composite scores in a same way, but we might have a little bit different outcome. So same thing with the mass and skill. So we calculate the percentile using a percent rank, calculate the z-score using standardize, and we use the mean and standard deviation of the group. Calculating composite score is quite easy. So these are the weighting factors. In this case, we can use percentage or we can use any fixed number. So I want to give skill a lot more influence on the composite score. So I want to say, okay, in a composite score, and that means composition with taking into account skill and mass, I want to give skill a little bit slightly more weight than maximum aerobic speed. Again, if I'm making a small-sided game where skill might be more dominant, more influencing the performance, so I might increase the weighting factor on the skill. And if I'm creating a drill or a small-sided game where maximum aerobic speed might be more important, then I might ramp up this percentage. So it's basically saying the ratio between these two, which one I want to give more weight. Let's say I want to give 70% to skill and 30% to maximum aerobic speed. We can sort these guys from smallest to largest. And as you can see, some of the guys gonna have a lower skill level, but a little bit higher maximum aerobic speed, but they're gonna still be ranked lower because skill, in this case, has more weight. So the easy thing is calculating this is skill rank or skill percentile times weighting factor plus maximum aerobic speed times weighting factor. That's it. Same thing for a z-score. So z-score of skill times weighting factor plus z-score of maximum aerobic speed times weighting factor. And we get the composite score. Again, these two might differ a little bit. So let's say these guys are sorted like this. If I sort it based on z-score, we're going to have slightly different ranking. So now the thing is setting these guys into a groups. Let's say I want to use composite scores ranking as a composite score, and I have, in this case, we're going to play 4v4, 4 groups of 4v4, that's equal 16. And the thing is, I want to create groups that they are balanced in a composite score, and that means that the group average of the composite score should be pretty equal. And let's say that equalness between groups we can express in a between group standard deviation. So this is a composite score using percentiles for group 1, group 2, group 3, group 4, and this is a mean of the group 1, group 2, group 3, group 4. So standard deviation is a variability between the groups, and what we want to do is we want to minimize this if we want to create balanced groups. We can do this manually. So if we sort this one, we know that we can choose the guy from first 4, second 4, first 4 quarter, second quarter, third quarter, and fourth quarter in this group, second, 2, and 3. So we might start 1, 5, 9, 13, right? And 2, 2. So we can do like this. Plus 4. I know I did a mistake here. So I'm gonna do. So what we did is for each group in a small side again, we choose one guy from a highest quarter, second quarter, third quarter, and fourth quarter. What we got here is a between group standard deviation. I'm gonna write it down. Let's say manual 6%, and between this is also manual. This is the same thing but using z-score. So this is 0.21 for manual. What I'm going to show you now is a nice and a cool trick using a solver in Excel. Solver is a free add-on tool. I think you can go to a file, add-ons, and you can select it because it's already in the Excel package, but it's not loading. You need to just select it. And solver actually help us optimize this in a better way and quicker. So let's say I wanna, what's the goal? The goal is to select the groups, select the players in each group so we have minimal difference between the groups expressed as a standard deviation. So we want this number to be as little as possible by using different combinations of the players within the group. So we're gonna use solver. I already put some parameters inside, but I'm gonna delete them so you can understand the rationale behind it. So what I want, the objective, I want this one between group standard deviation to be minimal, and I want to change these cells. So I want to find between group, I want to find the minimal between group standard deviation by changing these guys over here. Again, we need to put some constraints. So these guys, they can only be integer because they refer to a position in a table. So they cannot be 1.1, they need to be 1, 2, 3, 4, 5. And so, and next constraint is that these guys, one can only play in one group. So the numbers need to be different. We cannot have one here and one here. So one guy cannot be at two groups at the same time. So we need to say, okay, all of them, they need to be different. And one thing to speed up the calculations, we need to say the numbers here, they need to be less than or equal to 16 because we have 16 guys, and they need to be equal or higher than 1. So that's okay. There are a couple of solving methods. I tried a GRG, but sometimes it takes like 1 hour to solve this. So I took evolutionary. Sometimes it takes a little bit longer, sometimes it's like quick. And we click solve. So the solver is running in the background. You can check over here. And it finds the solution. You can get a report for this one. I will just click OK. So he finds the best grouping of the guys, so we get the least between group standard deviation. In this case, it's 0. It's not really 0, but because of the rounding, it's close to 0. So it's 0.22. Okay, I'll put it like this. So manually we got 6%, and using Solver we got 0.22. I'm gonna copy this one. Copy it as raw numbers. So this is a solution using percentile score, using using composite score, using percentiles or ranking. Now we can use composite score using z-scores, and we're gonna repeat the solver. That's why I copied this. So this is a solution using percentiles, and I'm gonna do the same using z-score. So I want to optimize this number. Before I do that, I'm gonna copy this so I know this was the number using ranking, using percentiles. And go to Solver again. So I want to optimize this number by again changing this. These two are linked, so if I change this number, this is gonna change. It's quite easier than doing all again for a different range of the player numbers. So I set it up like this. So I want to optimize minimize the between group standard deviation using z-scores, or composite score expressed using z-scores. Click solve. This might take a bit longer, but if it takes a bit longer, I'm gonna cut the video. So click solve. It's running in the background. A little bit time to grab some coffee. Still running. If you have a lot of players, this might take a bit more time because it needs to figure out the best solution. And the solution is here. So I'm going to keep the solution and the between group, let's say z-scores. So we got two different solutions using either percentiles as a way to express composite score, or using z-score as a way to express composite score between skill and maximum aerobic speed. Let's see if there's a. So manually we got 6%. Using using percentiles approach, we got 0.22, and using z-score we got 12.75 for between groups using percentiles, and using z-scores manually we got 0.21. In a percentile solution we got 0.15, and using z-scores to optimize we got 0.01. But in this case percentiles jump up a little bit. So again, depending which method you are using, either percentiles or z-scores, you might get slightly different groups. And as I said in the beginning of the video, each of them has pros and cons. In this case, percentiles doesn't, they are not affected by outliers that much. So there might be a guy who's a lot better than the group. He just jumps out. But they also don't take the difference between two guys in that degree as z-score. So the difference between 13th and 14th might be only one rank, so only one position down, but in real skill level or maximum aerobic speed, it might be much more than, for example, the difference between position 2 and 3, or rank 2 and 3. So the difference between these two guys and these two guys might not be reflected in the percentiles, but will be reflected in a z-score. But again, z-score is going to be affected by outliers. So again, pros and cons of both approaches. I would say if you have a nice group without too much outliers, use a z-score. And if you have outliers, the guys who are really bad or really jumping out, you might use the percentiles. Again, I'm gonna put this Excel workbook in a download below this video. Hope you learned something, and see you soon.